Welcome to this explainer. Whenever we turn on a tap in an industrial facility or even just look at a bottle of super pure water, it's really easy to wonder, how exactly did it get that clean? We naturally tend to think of water purification as just a dry, boring schematic of pipes and tanks. But what if we completely change our perspective for a minute? Today, we're going to frame this complex industrial process not as a textbook diagram, but as a thrilling survival gauntlet for a single drop of water. Our raw, untreated drop is about to go through a rigorous, high-pressure obstacle course, and only the absolute purest molecules are going to make it out the other side.
All right, let's dive right into this. What this essentially is the complete architectural blueprint of this gauntlet, a comprehensive 12-step reverse osmosis, or RO, plant diagram. Now, I know staring at this entire maze of cylinders, pumps, and intersecting lines all at once can feel pretty overwhelming. But don't worry, we're going to break this down step by step, isolating the different zones narratively so you understand exactly how every single piece of this giant puzzle works together.
So, we've chunked these 12 technical steps into 4 clear, easy-to-follow phases. First up, the raw water journey. Second, pre-treatment, where we filter out the threats. Third, the reverse osmosis core. And finally, the final polish and distribution. Let's get right into it.
Starting with phase 1, the raw water journey. Okay, so the journey of our little water drop kicks off right at the raw water inlet, pouring directly into step 1, the massive raw water tank. Now, at this point, this water's full of unknowns, right? We're talking minerals, random debris, harsh chemicals. It's basically just sitting there waiting for the process to start. But obviously, it can't push itself through this massive gauntlet on its own. And that brings us to step 2, the raw water pump. This mechanical powerhouse gives that intense, driving initial push that's absolutely crucial to force the water out of the tank and into the pressurized system. Our drop is officially on the move. Moving right along to phase 2, pre-treatment filtering threats. So now our water drop meets its highly trained security detail, and this detail is designed strictly to protect the fragile RO membranes waiting further down the line. Step 3 is the multimedia filter. Think of this as the first bouncer. It's packed with layers of media specifically designed to catch and trap all those large physical particles. Next, the water hits step 4, the activated carbon filter. This bouncer strips out the chemical threats, like chlorine, and this is vital because chlorine can literally destroy an RO membrane on contact. Finally, we've got step 5, which is an optional softener. This chemically neutralizes hard minerals that could cause some serious damage later on. So our water drop is getting much cleaner, but believe it or not, the security checks aren't over just yet. That brings us to step 6, the dosing system. Here, a control unit hovers over 2 smaller tanks, and it's actively conditioning the water. It does this by carefully injecting antiscalants or making really precise pH adjustments. Why? Well, it prevents any leftover microscopic minerals from clumping together and forming hard-scale buildup later on in the pipes or on the membranes themselves. It's a totally crucial preventative strike to keep the whole system running smoothly. Now, right before our water drop is finally allowed into the VIP room, it hits step 7, the micron filter. This is the absolute final checkpoint of the pre-treatment phase, and its job is to catch microscopic debris. To put that into perspective for you, a single human hair is about 70 microns thick. These filters, they're often catching particles smaller than 5 microns. There's literally no way anything big is getting past this point. If you make it past this, you are officially ready for the main event.
Which brings us to the climax of the journey. Phase 3, the reverse osmosis core. All right, here we are at step 8, the RO system. This is where the actual magic happens. It basically consists of 3 main components. First, you've got the brain of the operation, the control panel, which monitors the entire flow. Right next to it is the high-pressure pump. See, reverse osmosis requires an immense amount of force. We're talking about pushing water at hundreds of pounds per square inch. This pump violently forces our pre-treated water straight into those 3 long horizontal tubes, the RO membrane housings. And this is where the pure water gets separated from the impurities at a molecular level. So the crucial point here is that inside the membrane, the water's path literally splits in 2. Our little drop faces 2 completely distinct destinies. It's either going to become permeate, which is our pure, highly desirable product water, or it's going to become concentrate, and that is the reject water, heavily loaded with all those trapped impurities.
Think of it kind of like 2 distinct paths in our story. One path represents our hero, the pure permeate, the product water that successfully battled its way through the membrane and gets to move forward to the right. But contrast that sharply against the other path, That one represents the villain of our story, the concentrate. These are the rejected impurities that just didn't make the cut.
Let's actually briefly track that path of impurities to its bitter end. It leads directly down to step 12, reject water to drain. The system here is entirely uncompromising. Those rejected impurities, they are immediately flushed out of the plant and sent straight down the drain, guaranteeing they can absolutely never contaminate our pure product.
And that leads us to our final stage, phase 4, final polish and distribution. Following our surviving, newly purified water, we arrive at step 9, which is an optional post-treatment. Depending on what the water's final use is going to be, it might get a quick blast of UV light for a final sterilization, or maybe run through a mineral filter to add some specific tastes or properties back in. Once that final polish is done, the victorious water flows right into step 10, the product water tank. It has officially survived the gauntlet and now rests totally clean and pure, ready to be deployed. But how exactly is it deployed, right? Well, step 11 represents the distribution and use of this freshly purified water. And it's not just for drinking. This incredibly pure product might be used as process water in advanced manufacturing, or it could be absolutely vital boiler feed or cooling tower feed, keeping heavy machinery running safely without scaling up. Entire industrial facilities literally rely on the purity generated by this exact sequence to function. Now, before we wrap up, there are a couple of critical rules to keep in mind for the real world. First off, actual plant designs are going to vary depending on their capacity and the specific quality of the raw water coming in. Not every gauntlet looks exactly the same. They are completely tailored to the threat level. Second, regular maintenance is absolutely non-negotiable to ensure optimum performance and a longer membrane life. You can't just build this 12-step sequence and walk away. Those bouncers and pumps need constant care to keep the pure water flowing. So, we've basically followed a single drop from a murky, raw water tank, watched it run through a relentless series of chemical and physical bouncers, forced it through a high-pressure microscopic membrane, and delivered it as a perfectly pure product. It's an absolutely incredible feat of engineering hiding in plain sight. So I'll leave you with this to think about. How much does your local industry, your local power grid, or even your favorite beverage company rely on this exact invisible 12-step infrastructure to function safely every single day? I bet the next time you see a drop of pure water, you'll know exactly what it took to get there. Thanks so much for joining me on this explainer.